Hello and welcome to this episode of Math with Martinez. We are in our pre-cal unit on trig functions, and in this video we're looking at the transformations of both sine and cosine functions. So let's go ahead and dive on in. If we're translating sinusoidal functions, it's going to be much like the other functions we have seen up until this point. That means for the functions, when they're written in this format, in that transformational form, the h is going to represent, you guessed it, a horizontal shift. And our k is going to represent a vertical shift. Now, let's talk a little bit more about those vertical and horizontal shifts. If in your transformational form, if you're working with a k value, if a k value is introduced, then that is going to move it up if it's plus some k value, and if it's minus some k value, then that will move your graph of your sinusoidal function down. That wave is going to move down. It'll no longer be oscillating around like you see here, the x-axis, but it's going to move maybe up or be oscillating down here at a new axis, which we're going to talk about in just a moment. Our horizontal shift is also often called a phase shift. What's going to happen there is your cycle is going to begin and end at new points because of this phase shift. That means that the moment where this cycle is starting is going to move to the left if you have plus some h value, and that h value is going to be inside of a grouping symbol with the independent variable x, or it might be written with theta. And it'll be moved to the right and start later if it is minus some h value. So let's look at some examples and just work at identifying what translations occur here. So in this first example, what is happening to our parent function? To our parent function, there is a value added out at the end after your x, not with x, but after cosine of x. That, ladies and gentlemen, is going to be a vertical shift up 2 units. And that next example, what's going to be happening here? We have our sine function, sine of x, and then it's minus 1. So what's going to happen with this graph? What is the translation that occurs? That once again is a k value. Minus 1 is going to be a vertical shift down 1 unit. Now in example 3 and 4, notice what we've got. We've got our values inside of the grouping symbol. We have in this example 3 being added to the x, pi over 2. What that's going to cause is a phase shift to the right, pi over 2 units. So instead of our sine function beginning at the rotation 0, starting at the origin and then going up from there, like we have in this diagram right here, you see here's where the cycle begins and here's where it ends. Instead, what's going to happen is it's going to shift and start over here and wave a little bit later. At pi over 2 is where it's going to start. Instead of cresting at pi over 2, that's where it's just going to begin. And then it'll end pi over 2 later because the whole graph has shifted to the right. And here, with our cosine function in example 4, we are subtracting. Oh my goodness, I caught myself. You probably already caught this. but it would be not shifting to the right for this example. My bad. This is shifting left. Example 4 is going to shift to the right. This is shifting to the right pi units. So think about your cosine graph. How does our cosine graph look? Let me show you right here. The original cosine function looks something like this. Starts high, ends at a high note, goes kind of like doo, 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 doo. But because of this transformation, what's going to happen is the whole thing is going to shift over pi. So instead of starting here at 0, it's going to start here at pi. That's where our graph's going to begin. It's going to end much later. Instead of ending at 2 pi, it's going to end at 1 pi added to that. It'll end at 3 pi. So it'll end back up here at this high point. It'll come to a low point at 2 pi. So it'll do something like this. Right, and of course it'll continue on waving, but that kind of shows you one cycle how it has shifted over. Now, whenever you have this shifting of your graph vertically, like we see in blue in example 1 and 2, that's going to create a new horizontal axis. That axis is called the midline. And I referenced that in an earlier video. This is the line that our graph, about which it's oscillating, about which it's waving up and down, cresting, coming to a low point, cresting, coming to a low point called a trough. So this graph here, the original parent sine function, the line, the equation for the midline, here the midline for this graph is the line y equals 0. Now for this sine function graph that has been shifted vertically, the midline for this graph is the line y equals 4. So maybe you can answer this next question for me. What was it? What is the equation going to be in general for the midline of a sinusoidal function? It's going to be the line y equals, drum roll, k, where that is the k value that is either added or subtracted at the end of your sinusoidal function. So there you have it, you guys. Those are the translations that may be applied to your sinusoidal functions. If you had any questions about these, would you please take a moment and share those now? And until next time, stay fired up.